Good evening, I'm Laura Lee.
And I'm Dan Wolf. Thanks for joining us. The Great Lakes shipping season is off to a less than ideal start.
Right now, a dozen vessels are stuck in very thick ice in Lake Superior's Whitefish Bay, awaiting help that officials say may or may not be coming. Ships have to get through the bay before or after going through the nearby Sulaks.
Something unusual was reported under the Great Lakes, with many seismic signals in one day. But there's no strong proof from trusted sources. The lakes can create natural signals called microseisms that travel far, so it may not be anything dangerous. Something strange is happening beneath the Great Lakes. In just 24 hours, 87 seismic signals were reportedly detected across part of the region, enough to spark speculation, confusion, and a wave of alarm online. But here's the twist. I could not verify a credible public source, such as the USGS or a major seismology organization, confirming a real Great Lakes event described exactly that way. What is real is that the Great Lakes can generate powerful seismic-like noise, known as microseisms, and USGS researchers have shown those signals can spread hundreds of kilometers inland. That means the mystery is not whether the Great Lakes can produce unusual seismic signals. They absolutely can. The mystery is what those 87 signals actually were. Were they tiny earthquakes? Wave-generated ground vibrations? Ice? Pressure changes? Industrial noise? Or some unusual combination of natural forces? And that is where this story gets unsettling. Because when a region not known for constant earthquake drama starts showing clusters of unexplained seismic signatures, people immediately ask the same question. What is really moving below the surface? For most people, the Great Lakes are associated with shipping, storms, freezing winters, lake effect snow, and vast open water. Not seismic mystery, not ground motion, not instrument readings that make scientists stop and look twice. But that calm image hides a deeper truth. The Great Lakes are capable of generating seismic energy that can be detected far from the shoreline. A USGS-led study found that Great Lakes microseism signals were observed at distances greater than 300 kilometers from the lakes, driven by interactions between wave energy and the lake environment. That matters because it means a strange burst of signals in this region does not automatically point to a classic earthquake swarm. And yet, that does not make it harmless or boring. In some ways, it makes it more intriguing, because once the instruments begin lighting up, the real challenge is interpretation. What exactly are the sensors hearing? What kind of energy is moving through the ground? And why did it happen in that pattern, in that place, at that time? Those are the questions that turn a routine detection into a full-blown mystery.
Why this story took off so fast? The reason a headline like this spreads instantly is simple. It combines three things people react to immediately: the Great Lakes, seismic signals, and expert uncertainty. That combination is powerful. The Great Lakes feel old, stable, almost permanent. They are not California. They are not Alaska. They are not usually where the average person expects a burst of seismic weirdness. So when people hear that dozens of signals were detected in a single day, their minds race toward the biggest possibilities first. Earthquake swarm, fault movement, volcanic activity, something building underground, something hidden beneath the lakebed. And once the phrase "experts confused" gets added to the mix, the internet does what it always does. It fills in the blanks with fear. But this is where the real story becomes more interesting than the viral version. Because in the Great Lakes region, seismic signal can mean more than one thing. Instruments can detect true earthquakes, but they can also pick up wave-driven microseisms, atmospheric effects, sonic phenomena, and other vibrations that do not fit the popular image of a quake tearing through the crust. USGS also notes that some mysterious booms and shaking reports can come from a range of causes, including human activity, sonic booms, or unexplained local events rather than tectonic rupture alone. So now the story becomes less about panic and more about a puzzle. What was the source? What made the instruments react? And why did the pattern look unusual enough to get attention? The Great Lakes are not seismically silent. One of the biggest myths about the Great Lakes region is that it is geologically quiet. Quiet compared with the most active earthquake zones? Yes. Silent? Not even close. Michigan, for example, has a documented history of seismic disturbances, though state materials describe the number of earthquakes with epicenters actually in Michigan as relatively small. A Michigan geological report notes that reports of earthquakes in what is now the state date back centuries, even if many felt tremors actually came from neighboring regions. That historical context matters, because when people hear about seismic signals in the Great Lakes, they often assume the idea itself is impossible. It is not impossible. It is just less familiar. The region has ancient faults, buried structures, glacial legacy features, industrial vibration sources, and enormous water bodies capable of interacting with the atmosphere and shoreline in complex ways. On top of that, the lakes themselves can generate widespread microseisms under the right wave conditions, meaning the sensors may detect energy that feels earthquake-like without being a classic earthquake at all. That is what makes a story like this so compelling, because the Great Lakes sit in that unsettling middle ground where the public expects stability, but the instruments sometimes tell a more complicated story. What seismic signals actually mean. Let's slow this down for a moment, because this is where most viral stories go wrong. A seismic signal is not automatically an earthquake. That may sound obvious, but it changes everything. A seismometer records motion. It does not record a caption. It does not tell you by itself, this was a tectonic quake, or this was wave energy, or this came from blasting, or this came from ice cracking. It records vibration. Then, experts interpret the shape, timing, frequency, distribution, and context of those signals. That is why a burst of 87 signals can be so confusing in the first place. Not because scientists know nothing, but because classification takes work. USGS research on Great Lakes microseisms shows that lake-generated signals can spread widely and vary with the environment, while other unusual sounds and ground motions can come from multiple natural and human causes. So, if dozens of signals appear in a short window, experts would likely ask questions like these. Were the waveforms similar? Did they come from one consistent location? Were they shallow or deep? Were they tied to weather? Were they near known industrial activity? Were they recorded across multiple stations in a pattern consistent with lake microseisms? Or did they resemble a swarm of tiny crustal events? This is the kind of analysis that separates science from speculation. And until that analysis is public and confirmed, any dramatic certainty is usually premature. The most plausible, natural explanation. If you strip away the drama and look at what is publicly documented, one of the strongest explanations for unusual Great Lakes seismic detections is microseism activity. That may sound underwhelming at first, but it is not. Microseisms are a reminder that large lakes are not passive surfaces. Wind, wave energy, shoreline interactions, and basin geometry can generate ground vibrations strong enough to be detected far beyond the lakes themselves. The USGS study on Great Lakes microseisms found widespread influence across the United States, showing signals recorded more than 300 kilometers away. That is extraordinary. It means weather over the lakes can, in effect, shake the ground across a broad region. And once you understand that, a lot of mysterious seismic activity starts looking less supernatural and more physically complex. Still, plausible is not the same as proven. If the reported 87 signals were all part of one weather-driven microseism episode, that would explain the quantity without implying a hidden fault suddenly woke up. But without a verified event bulletin or detailed waveform analysis, we cannot say that is what happened, only that it fits a known mechanism. And in a story like this, that distinction matters.
The more dramatic possibility, a swarm.
Of course, the explanation people jump to first is an earthquake swarm. That is the version that feels cinematic. Dozens of small signals, short period, single region, no obvious explanation. And yes, swarms do happen in the world of seismology, but the Great Lakes are not known publicly, at least in the sources I could verify, for an officially confirmed, ongoing, 2026 crisis involving 87 mysterious tectonic events in 24 hours. I found no credible public USGS or SSA source confirming that exact claim. That absence is important, because when a genuine swarm large enough to alarm the public occurs, there is usually some trace in official bulletins, news reporting, or scientific communications. Instead, what turns up publicly is long-standing evidence that the Great Lakes produce seismic-like signals through wave processes, plus broader background information showing the Midwest is not entirely free of earthquakes. So could a swarm be possible, in principle? Yes. Is it verified here? Not from the sources I found. And that is why experts confused may actually be more accurate than the headline itself. If there was a burst of signals, the real confusion may be over classification, not over some confirmed, hidden cataclysm. Why the Great Lakes feel so creepy in stories like this? There is a reason the Great Lakes make seismic stories feel more eerie than they might elsewhere. It is the setting. Everything about the lakes already carries a sense of scale and mystery. Cold depths, violent storms, shipwreck history, long winter ice, hidden underwater terrain, vast horizons that feel more like inland seas than lakes. So when you add the idea of unexplained seismic detections, the whole region suddenly feels like it is hiding something. That emotional effect is real, even when the science remains uncertain. And uncertainty is where stories like this thrive. Because the moment you tell people that sensors detected dozens of unusual signals beneath or around a giant freshwater system, they immediately imagine the lakebed itself shifting in silence, an ancient fault awakening, pressure moving through buried rock, cracks hidden under sediment. The reality may be far less dramatic, but emotionally, the Great Lakes are perfect for this kind of mystery. They are familiar enough to feel personal, and vast enough to feel unknowable.
What experts would actually do when a strange cluster of signals appears? Real experts do not start by asking the scariest question. They start by asking the most boring, useful questions. Station quality, timing consistency, signal frequency, spatial clustering, weather overlap, anthropogenic noise, known quarry blasts, ice dynamics, lake wave conditions. That is how science protects itself from overreaction. Seismologists and geophysicists are trained to separate signal from story. If the detections were caused by wave energy, they would look for correlation with storms and characteristic waveform patterns. If the detections were local earthquakes, they would look for consistent origins and arrival times across stations. If the source were industrial, atmospheric, or something else, they would test those explanations against the data. USGS materials on Great Lakes microseisms and on unexplained booms both emphasize that unusual ground or sound signals can arise from multiple causes and require careful interpretation. That process is not dramatic, but it is exactly why confused should not be misread as clueless. Sometimes experts are confused because the data are genuinely mixed, sometimes because early reports are incomplete, and sometimes because the public headline races ahead of the actual evidence. The internet's favorite move, filling the gap. The minute uncertainty appears, the internet rushes in to replace it. That is almost guaranteed. If there were 87 signals and no instant clear explanation, online theories would multiply within hours. Earthquake buildup, government cover-up, magma movement, military testing, secret drilling, a coming major quake, lake monster if people are in the mood. But none of that is evidence. And one thing I noticed while checking this claim is that the exact wording seems to circulate much more in sensational spaces than in official or mainstream scientific reporting. What does exist in credible literature is the reality of Great Lakes microseisms and the broader fact that unusual seismic-style detections do occur in and around large water bodies. That does not make the story fake in a simple sense. It means the framing may be racing far ahead of the verified explanation.
And that is often where the most viral fear comes from, not from what is known, but from what is left open.
Could weather really do this? This may be the most surprising part of the whole story. Yes, weather can create seismic signals. Not metaphorically, literally. Large waves, pressure systems, and lake interactions can produce measurable ground vibrations, and Great Lakes microseisms are a documented phenomenon. The USGS study showed that these signals can be widespread and significant enough to appear at seismic stations far inland. That means the lake does not need to rupture like a fault to create a strange burst of detections. It may only need the right physical conditions. And if that is what happened, it would explain why people heard 87 seismic signals and assumed the crust was cracking apart, while experts looked at the same situation and said, "Hold on, we need more analysis." That gap between public imagination and expert caution is where confusion lives. And frankly, it is why stories like this are so irresistible, because the truth may be both less dramatic and more fascinating than the headline. A giant freshwater system, through weather and wave physics alone, can mimic part of the language of earthquake activity. That is wild, even without a disaster. The Great Lakes and hidden motion. There is also a bigger idea underneath all of this. The Great Lakes region may look calm from the surface, but calm landscapes are often full of hidden motion. Not constant catastrophic motion, but processes, pressure, wave forcing, ice stress, buried structures, ancient faults that are mostly quiet but not erased. The Midwest is not outside geology. It is just different geology. Michigan's documented seismic history is limited but real, and scientific work has shown that even non-tectonic lake processes can generate regionally important seismic signatures. That should change the way people think about the story, because maybe the most important takeaway is not whether one viral number was perfectly reported. Maybe it is that the Great Lakes are far more dynamic than most people realize. They move air, they move water, they shape weather, and under the right conditions, they can even move the ground enough for sensitive instruments to notice.
What we can say with confidence here is what can be said responsibly. I could not verify a credible official source confirming that 87 seismic signals in 24 hours happened exactly as stated in the title. I also could not verify a major public statement from experts saying they were baffled by such a specific event. But several related facts are solid. The Great Lakes can generate microseism signals detectable far from the shoreline. The Great Lakes region is not completely free of earthquakes or seismic disturbances. And unusual booms, tremors, or instrument detections can come from multiple causes, which means caution is essential before labeling anything a hidden quake swarm. In other words, the mystery sits in a real scientific world, not in fantasy. Just in a world where the data may be more complicated than the headline suggests. Why this story still matters. Even if the viral framing turns out to be exaggerated, this story still matters. Because it reminds us how little most people understand about the signals moving through the world beneath their feet. We think of lakes as surfaces. We think of earthquakes as events. But in reality, Earth is full of vibrations that blur those categories. Storms can create seismic noise. Water can imitate tectonic motion on instruments. Ancient stable-looking regions can still produce tremors. And when something unusual happens in a place we assume is quiet, the result is immediate unease. That unease is not irrational. It is human. People want certainty from the ground. They want lakes to stay lakes and faults to stay somewhere else. But science keeps teaching the same lesson over and over. The planet is more interconnected, more dynamic, and more surprising than it first appears.
Conclusion. So what really happened in the Great Lakes? Here is the honest answer. I could not verify a public official source for the exact claim that 87 seismic signals were detected in 24 hours and left experts baffled. But I could verify that the Great Lakes are capable of producing widespread microseism signals, that the region has a real, though relatively modest history of seismic disturbances,
and that unusual ground motion detections often require careful analysis before anyone can say what they truly mean. And maybe that is the most unsettling part of all. Not that the answer is definitely catastrophic, but that the answer is not instantly obvious. A burst of seismic signals in the Great Lakes region does not automatically mean disaster, but it does remind us that beneath even the most familiar landscapes, motion is always there, waiting to be measured, interpreted, and sometimes misunderstood. So whether those 87 signals were wave-driven microseisms, small local events, instrument noise, or something more complicated, one thing is certain: the Great Lakes are not as still as they look. Subscribe and hit the bell icon for more deep dive mystery stories, science breakdowns, and real-world investigations into the strange signals our planet sends every day.